Assalamu alaikum students. Good evening to everyone. Are you able to see the slide? Can anyone please confirm? Are you able to see the slide? Yeah, thank you. So before starting today's session, I would like to tell you all the assignment 2 is already available on the Blackboard. I hope you all able to access it. And if anyone is having any difficulty to access the assignment 2 file, please let me know as early as possible. But from my side, I have double checked the link. I mean, the URL is working properly. So there is no issues at all in the assignment too. Okay. So coming to today's class, we are going to start with a new module, that is module 11, where we are going to learn about the cloud and IoT security. So if you look at these concepts related to this cloud and IoT security, here we are going to learn many things. What is a cloud technology and what are the countermeasures that we need to follow, and what is IoT and what are the various procedures that we need to follow in the IoT security, all these things. So if you all remember, in the previous session, we learned about virtualization, hypervisor, container, then virtualized infrastructure, how to handle the software defined networks. See, all these technologies are the foundations of cloud computing technology. So now let us learn with the cloud computing what actually it means, particularly based on the definition which is given by NIST. Okay, and then we will see what are the components out there, how we can provide the security, all these things. So the cloud computing is a model for enabling ubiquitous, convenient, on-demand network access. As you can see, the official NIST SP 800-145 definition, it clearly states that the cloud computing is a technology that allow the user to access the computing resources like servers, storage devices, applications, and networks over the internet whenever they needed them without, but without purchasing the physical devices or managing the physical infrastructure. So that means instead of buying expensive hardware, the organizations can rent the computing resources from the cloud providers. And these resources can be in any form like server, storage, database, application, network. It can be in any form. So why the cloud computing is a very popular? So the cloud computing provides easy access, scalability, flexibility, lower infrastructure cost, faster deployment, and the organizations are going to pay only for the resources that they are going to use. Like for example, let us say you have a startup company and you want to launch a website using the cloud server instead of purchasing expensive physical hardware and all. So the cloud computing have five essential characteristics. Let me show you the diagram. Number one, broad network access. Number two, rapid elasticity. Then three, that is measured service. Number four, on-demand self-service. Number five, the resource pooling. Okay, so now if you see the first thing, the broad network access. So the cloud services are available over a network, typically the internet. So the user can access the cloud resources from any different device. Either the user can use their laptop, desktop, their smartphone, or even the tablet. After that, we have another characteristic, that is the cloud technology is having rapid elasticity. So the cloud resources can quickly increase or decrease according to the demand. So that when the workload increases, more computing resources are automatically allocated. When the demand decreases, unused resources are going to be released. It is going to be released. And the third characteristic is like measured service. See, the cloud computing provides measured resource usage, like for example, CPU usage, storage, network bandwidth, memory, processing time. So the customers are going to be billed according to their actual usage. See, on demand self service. See, this characteristic clearly states that the user can obtain the computing resources whenever they need them without waiting for the manual approval from the service provider. And then the last characteristic is on demand self service. So here you can see the resource, the cloud provides to maintain the cloud providers, they used to maintain a large pool of physical computing resources. So these shared resources are allocated to the multiple um, customers according to the demand. So the user can obtain the computing resource whenever they need them without waiting for manual approval from the service provider and all. So here if you see, according to the NIST SP 800-145, the cloud computing is a model that provide the convenient on-demand network access to a shared pool of configurable computing resources. So it includes the servers, storage, applications, and the services with the minimal management effort. So here we will identify five essential characteristics as like broad network access, rapid elasticity, measured service, on-demand self-service. So, and also the resource pooling. So together, all these characteristics, it made the cloud computing more flexible, scalable, and mainly cost-effective for widely accessible end users. And then models in the cloud service. See, according to the NIST SP 800-145, the cloud computing provide mainly three service models. One is the software as a service. Number two, platform as a service. Number three, the infrastructure as a service. So these are called nested service alternatives, which means that each service model will provide a different level of responsibility between the cloud provider and the customer. So the NIST SP 800-145 define these three service models, which can be viewed as a nested service alternative. So it starts with software as a service, platform as a service, and infrastructure as a service. So the customer will gain more control, more flexibility, and more management responsibility. So if you see the software as a service, it is a cloud service model in which the customer use the software application provided by the cloud provider without managing the underlying infrastructure or even the platform. So the cloud provider manages server, storage, operating system, platform, application software, but the customer simply use the applications alone. And when it comes to the platform as a service, it is also a cloud service model in which the provider will supply a development platform, but the customer will develop, deploy, and manage their own applications. So that means the cloud provider will manage the hardware, server, storage, operating system, runtime environment, all these things. So the customer is going to manage the applications and application data. After that, we have another infrastructure that is, another plan model, that is infrastructure as a service. So this is also a cloud service model that provide the customer with access to computing infrastructure like virtual servers, virtual storage, and networking resources and all. See, with all these models, the cloud computing technology delivers the services through the NIST defined service models like SaaS, PaaS, and IaaS. So each one is providing a different balance of the customer control and the cloud provider responsibility, enabling the organizations to choose the most appropriate level of management, flexibility, and infrastructure which can support for their computing needs for their computing needs. And then cloud deployment models. See, while the service models describe what type of cloud service is provided, deployment models also going to describe where the cloud infrastructure is deployed and who is going to own that and manage that. So here we have four models. One is public cloud model, private cloud model, community cloud model, and hybrid cloud model. So first let us see the first two. So the cloud deployment models will describe how the cloud infrastructure is deployed and it is managed. So a public cloud is owned and managed by a cloud provider. They made available to the general public or for a large industry group. So this is going to offer the cost advantages, but it will introduce some security concerns because the infrastructure is shared here. And then if you look at the private cloud, it is implemented within an organization's internal IT environment, or it is managed exclusively for that organization. So providing greater security, easy resource sharing, and rapid deployment of services to the organizational entities. So here we have another uh, two deployment models. One is the community cloud and another one is the hybrid cloud. See, a community cloud will combine the features of private and public cloud, which will be providing the restricted access, but also it is allowing with multiple independent organizations having a common requirement to share the cloud resource. So the infrastructure may be managed by the participating organizations or by a third party, and also it may exist on premise or off premise. That means on location or off location. So a hybrid cloud, on other hand, it combines two or more cloud deployment models like private, community, and public cloud, which will allow the organization to store the sensitive information in a private cloud while it is using the public cloud for less sensitive workloads, making it a flexible and attractive solution, particularly for the smaller businesses and all. For the smaller businesses and all. See, it is very important that when you have this balance of cloud deployment models, we can have the security, flexibility, and cost by placing sensitive workloads in private cloud and less sensitive services in the public cloud. And then coming to the cloud computing. See, the cloud computing reference architecture is clearly defined by the NIST, National Institute of Standards and Technology, SP 500 292. So the NIST cloud computing reference architecture is given here in the diagram. You can see that. So it is a conceptual framework that is developed by NIST to describe the cloud computing services using a common reference model. It is going to provide the common way to describe the cloud system, to understand what are the cloud services, and to discuss the cloud computing concepts by comparing the cloud solutions. So it is going to serve as a reference but not as a specific cloud product. Like, for example, in our university, we may have the cloud provider, and there is a cloud provider like Amazon or Microsoft. They can use the NIST reference architecture as a common language when discussing how a new cloud based learning management system like Blackboard should be operated within the university and all. See, the thing is that it is clearly depicted by the NIST, I mean the reference architecture as you are seeing in this picture, and this one is widely used as a common language for cloud computing. So rather than prescribing a specific implementation, it helped the organizations, cloud providers, researchers, and even the customers to discuss the cloud systems using consistent terminology. And this common framework will simplify the cloud planning, service comparison, standard evaluation, and the analysis of a security, interoperability, and portability by making it an essential reference for the modern cloud computing. And then now the main important part comes, that is the guidelines recommendation. I mean the NIST guidelines and recommendations given for cloud security and privacy issues. See, it is one of the most important topic in the cloud security also. The NIST guidelines and the recommendations on cloud security and privacy issues are very important, because as many organizations nowadays, they move their applications and their data into the cloud. So they must ensure that the cloud environment remains secure, reliable, and also privacy preserving. So, to help achieving these, the National Institute of Standards and Technology has clearly published the guidelines that identify the major security and privacy concerns the organization should address before adopting the cloud computing technology. So here, if you see, the cloud computing offers many benefits like scalability, cost saving, flexibility, easy resource sharing, but it also introduces the security and privacy challenges like protecting sensitive information, controlling the user access, securing the cloud infrastructure, maintaining the user privacy, meeting the legal and regulatory requirements like this. So the NIST guidelines are recommended the best practices that developed to help the organizations for securing the cloud environment, for protecting the sensitive data, for preserving the user privacy, and for managing the cloud related risk, and also to improve the trust in cloud computing technologies and all. See, the main purpose of the guidelines is the NIST has clearly recommended and the recommendations are aiming to help the organizations to mainly understand the cloud security risk and to protect the confidential information, to maintain their integrity, and also to support the secure cloud adoption. Whereas they have, in order to do all these things, they have to maintain the architecture in a secured way, and also they have to identify and maintain the user access management process. So there are goals like confidentiality, integrity, availability. So the NIST recommendations support the three fundamental security objectives like to protect the information from unauthorized access and to ensure the data remains accurate and unaltered, and also it will ensure the cloud service remain accessible whenever it is required. See, the thing is that, like for example, let us say there is a bank, let either it is Al Rajhi Bank or something like that. They want to move selected financial applications to a cloud environment. So using these NIST cloud security and privacy guidelines, the bank will evaluate the cloud risk, protect, and they want to protect the confidential customer information. They want to establish the strong authentication mechanism, and continuously they want to monitor the cloud activity and implement the security controls that support confidentiality, integrity, availability, and the privacy requirements. So then we have the security issues for cloud computing. See, even though the cloud computing is offering many advantages like scalability, flexibility, and cost saving, the organizations must carefully evaluate the security risk before moving their systems and data to the cloud. So, here, if you see, the security is, I mean, when an organization move from its own data center on site to the cloud, that is off site, its data and applications are no longer completely under their direct physical control. So therefore, the security becomes one of the most important factor in deciding whether to migrate or not. So here, the thing is, as we know, the security is going to be the major consideration when adopting the cloud computing, and also the organization should address the security concerns before migrating from on-premises systems. So the important issues include like ensuring the availability, maintaining the auditability, evaluating the internal and external threat, and understanding the shared responsibility model, where the cloud users secure their applications, the cloud providers protect the physical infrastructure and the parts of the software environment, and both they are going to share the responsibility for intermediate software layers. So the organizations should also verify how the providers are going to protect against the theft, denial of service attack, and the inadvertent data loss before selecting the cloud service. See, most of the cases, successful cloud adoption requires always the organizations to address the security concerns before migrating by ensuring the availability, auditability, protection against the internal and external threats. This is very important. And then we need to understand what are the various risks and what type of countermeasures that we have for that. See, the Cloud Security Alliance, CSA, there are two important cloud specific security threats that are abuse and immoral use of cloud computing and insecure interface and APIs. So here it recommend various countermeasures that to reduce to reduce the misuse of cloud services through a very strict customer registration and validation, and then credit card fraud monitoring, and then network traffic inspection and monitoring the public blacklist. So to protect the cloud APIs, on other hand, the organizations should also analyze the security model of the cloud security providers interface. So it can be implemented with a strong authentication and access control, and also they have to understand the dependency chain which is associated with the API before the deployment. So when they do all these things, the Cloud Security Alliance, where the organizations can strengthen the cloud security by preventing the abuse of cloud service through a strict customer validation, fraud detection, traffic inspection, and blacklist monitoring, while protecting the cloud management interfaces by evaluating the API security, implementing strong authentication and access controls, and also understanding the API dependencies before deploying the cloud services and all. So then we have another few risks, and also we have the countermeasures for all these purposes. See here in this, we have the malicious insider and the shared technology issue. So if the threat is a malicious insider, and then we need to make sure the countermeasure, that is by enforcing a strict supply chain management and supplier assessment, then specific human resource requirements in legal contracts, and also we need to ensure the transparency in information security management practices and the compliance reporting, and determine the security breach notification processes. So the shared technology issues is one of the major concern or threat in the cloud security. So for this, we can implement the countermeasure like the security best practices for installation and configuration, and monitor for unauthorized changes and activity. Uh, so we can promote a strong authentication and access control for administrators, and we can enforce the service level agreements for patching and vulnerability remediation, and also we can conduct the vulnerability scanning and configuration audits, all these things. So with all this, it will require sometimes the service level agreements for patching and vulnerability redemption, and also the regular performance of vulnerability scanning to avoid the shared technology issues and all. So by doing all these things, the Cloud Security Alliance is clearly recommending the countermeasures to reduce the risk of malicious insider and the shared technology issues. And also, see, we have some more issues and the countermeasures. So here, if you see that the data loss or leakage, data loss or leakage, see, the Cloud Security Alliance is clearly mentioned that the organization should protect against the data loss or leakage by implementing a strong API access control, encrypting the data in transit and at rest, analyzing the data protection throughout the system lifecycle, and securely managing the encryption key. So to reduce the risk of account or the service hijacking, the organizations should prohibit the credential sharing, implement two-factor authentication, continuously monitor for unauthorized activity, and we need to understand the cloud service provider security policies and service level agreement. So to address an unknown risk profile, the organization should obtain the relevant logs and understand the cloud infrastructure details, and enable the continuous monitoring and also alerting in all these cases. See, as the CSA clearly mentions that the organizations can reduce the cloud security risk by protecting the data through the API, access control, encryption, and secure key management, where they can prevent the account hijacking through the credential protection, two factor authentication, and continuous monitoring. And also, they can reduce the unknown risk by obtaining the cloud security logs and understanding the infrastructure details, and also implementing the effective monitoring and altering mechanisms and all. And then how the data protection is happen in the cloud, because the cloud technology is mainly used for what? To store the data. This is the major purpose, right? So data is the most valuable asset for any organization. So when data is stored in the cloud, the organizations must ensure that it remain confidential, accurate, and it should be accessible throughout its entire life cycle, its entire life cycle. See, the data must be protected while it is stored, while it is being transmitted, while it is being processed. So protecting only the stored data is not sufficient in the cloud technology. So when the organizations move the data, which is on site, I mean local data, to the cloud, the risk of data compromise increases because the data is stored remotely, the cloud resources are shared. Sometimes the multiple users may access the cloud services. The data will travel across the networks. So therefore, the strong data protection mechanisms are very, very essential. So that is why the data should be protected while it is stored during the transmission and while it is being processed. The client can protect the data in transit using encryption mechanism and it is being processed. So the client can protect data in transit while using the encryption and enforce the access control, while the cloud service provider also participates in the security depending on the cloud service model. So for static data, it recommends that encrypt the database and store only the encrypted information with encryption key remaining unknown to the CSP whenever possible. But however, even with these precautions, the data corruption and denial of service attack remain important as a security risk. So the data protection in the cloud is happened with two models. One is multi-instance model and another one is multi-tenant model, multi-instance model, and multi-tenant model. So these models will differ, like how the cloud subscribers use the database resources and who is responsible for managing the security. So multi-instance model is going to provide the unique database management system which will be running on a virtual machine instance for each cloud subscriber. So a multi-instance model is a cloud database model where each subscriber has a separate database management system which will be running on its own virtual machine instance. That means in this model, each customer will receive a separate database instance. So each instance will run independently so that the customer do not share the database management system with other subscribers. So that means it is providing a very greater isolation, a greater isolation. So then the second model is multi-tenant model. So a multi-tenant model is also a cloud database model where multiple subscribers, they call it as tenants, they share the same database environment. So that means instead of separate databases, multiple organizations, they will share one database platform and each subscriber will access only its own information. Like for example, there are several companies, they will use the same cloud CRM platform, but each company can only access its own customer records alone. See, the thing is that the cloud subscribers with a separate database management system will running on its own virtual machine will allow the subscriber to manage role definition, user authorization, and security administration independently. But on the other hand, the multi-tenant model provides a shared database environment where the multiple subscribers will share the same infrastructure. So each subscriber data is separated using the subscriber identifiers, so giving the appearance of exclusive use while relying on the cloud service provider to establish and maintain a secure database environment. And then the cloud security as a service. See, instead of like purchasing, installing, and maintaining the security software on their own system, the organizations can obtain the security services directly from the cloud service provider. Like for example, you have a company and you already purchased the cloud services through Amazon Web Service, Amazon Cloud Service, or then this one, what is that? Microsoft Azure or cloud, Google Cloud, something. So beyond that, again, if you are purchasing the security policies separately, instead of that, what you can do is we can directly obtain the security services from the cloud service provider itself. So the cloud security is also, I mean, security as a service is a cloud service in which the security applications and services are going to be delivered by a cloud service provider through the cloud. So instead of installing the security software locally, the organizations subscribe to the cloud based security services and all. So here we need to remember that the software security as a service will provide the software through the cloud, and the security as a service will provide the security software and services through the cloud. Therefore, it is a specialized form of software as a service focused on security alone. Security alone. So here, importantly, the main benefits it include: the centralized security service will be possible, cloud-based protection is possible, support for both cloud and on-premise system is possible, multiple security functions through one service is going to be provided. So the security as a service, which is mainly, as you can see in this diagram also, it is a cloud-based software as a service which is offering that delivery offering that delivers the security applications and the services for protecting both the cloud and on-premises environment through the capabilities like identity and the access management. So the data loss prevention will be there, web and email security, security assessment, intrusion management, then encryption, business continuity and disaster recovery, network security. Everything is going to be possible in these cases. And then we have OpenStack. We have the OpenStack. See, unlike the software as a service, platform as a service, or infrastructure as a service, here the OpenStack is not a cloud service model. Instead, it is a software that is used to build and manage the cloud infrastructure. So the OpenStack is an open source software project of the OpenStack Foundation, whose aim is to produce an open source operating cloud operating system. Okay, so what is OpenStack exactly? See, the OpenStack is a open source cloud software platform where it is developed by the OpenStack Foundation for building and managing the cloud computing environments. So OpenStack is freely available. The organizations can use it to build their own cloud infrastructure without purchasing proprietary cloud management softwares and all. See here, if you understand, the best benefit of this OpenStack is it is a open source. It is flexible with the deployment. It support large cloud infrastructure. It is suitable for the organizations of different sizes. It is efficient with the management of virtual servers, and it support both public and private cloud. And it is also multi-tenant capability, and it is also a multi-tenant capability. So the best practice of using this one is, see, OpenStack is widely used in data centers and cloud computing products where it is providing a multi-tenant infrastructure as a service where it is going to support both public and private clouds, and it is designed to be simple to implement while remaining massively scalable to the cloud deployment of any size So if you see more in detail about the OpenStack, it is just as every operating system which needs a mechanism to identify the users, to verify their identity, and to control and to control the access to the various resources. So here the OpenStack requires a centralized security service, and this role is performed by the keystone. This role is performed by the keystone. So the keystone is the security module of OpenStack, and it provides the authentication, authorization, and other shared security services which required for a cloud computing environment. So the OpenStack consists of many cloud services. So before the user can access these services, their identity must be verified. So the keystone performs their security function. Like for example, in our university, if we are using the OpenStack to manage the virtual missions, So before an IT administrator will create a new virtual server, the keystone will verify the administrator's identity and the permissions. So instead of each OpenStack component implementing its own security, all OpenStack services will use the keystone because it provides the central authorization, centralized authentication, and consistent security management process. So here, that is what I try to say. The keystone is going to be the central security model of the OpenStack, which enable to secure the cloud operations by providing the shared security service, including identity management, token-based authentication, service catalog management, and the policy enforcement. So it will ensure the consistent authentication and authorization across the entire OpenStack cloud infrastructure. OpenStack cloud infrastructure. See, sorry, we need to understand how launching a virtual machine in OpenStack is happening. See, while the keystone manages the security, on other hand, we have a mechanism called Nova, which manages the computer resources, especially for the virtual missions. So Nova is the OpenStack management module, and it is going to be responsible for creating, controlling, scheduling, and managing the virtual missions in an infrastructure as a service cloud, in an infrastructure as a service cloud. So Nova is going to act like the computer manager for the OpenStack. So it is responsible for handling all the operations which are related to the virtual machines. See, whenever there is a user who requests a new virtual server, the Nova will perform the required management task. So here Nova is going to be the OpenStack management module, which is responsible for controlling the complete lifecycle of virtual machine by spawning, scheduling, managing, and decommissioning the compute instances. So it will be enabling the organizations and cloud services to provide the delivery of scalable on-demand infrastructure as a service, cloud computing resources and all. And now we are going to start with a very important topic, that is IoT. See, the Internet of Things. So, in short form, it is called as IoT, which is transforming the way how the devices are going to communicate and interact with each other. So, every day, the objects like home appliances, sensors, vehicles, and wearable devices can now connect to the internet, and they can collect the data, and they can make the intelligent decisions, so here the thing is, we need to understand, like, a internet of thing, IoT is a network of smart devices, appliances, and sensors that are connected to each other and the internet to collect, exchange, and use the data. So IoT will connect the physical objects so they can collect the information, share the information, respond automatically, and they can support intelligent decision making. So here the IoT devices will contain small communication modules. We call it as transceivers, sensors, and embedded processors. So these allow everyday objects to communicate wirelessly. Okay, and then the IoT will enable the communication between people and devices, as well as the devices with other devices with the internet and cloud systems. So this will be supporting the connectivity and the data management. So most of the IoT devices will be generating the low bandwidth, low frequency data, while the devices such as like the high resolution security cameras and voice over internet protocol phones, these require a high bandwidth streaming. So beyond collecting sensor information, the IoT devices can act on their environment, and in some cases it will modify their own behavior to support the automated management of larger systems of the larger systems. And then the evolution of IoT. See, the internet has evolved through four generations of end systems, with the fourth generation representing the internet of things. So the evolution of IoT is based on four generations of deployment, starting with information technology, operational technology, personal technology, and the sensor actuator technology. See, the internet did not become IoT overnight. It evolved gradually through the four generations. Each generation they have introduced new type of connected devices and all. So here importantly, the internet has evolved through these four generations of deployment. The first generation, information technology, it mainly focused on traditional computing device like PC, server, router, firewall, and these are connected to the wired networks. So the second generation, that is operational technology, it introduced embedded computing devices like medical machinery and kiosks. These are using wired connections. The third generation personal technology brought portable wireless device like smartphones and tablets. Finally, the fourth generation sensor or actuator technology, it represents the Internet of Things, that is characterized by the billions of embedded devices which communicating wirelessly as part of a larger interconnected systems and all. See, the thing is that every IoT enabled device is built from several essential components that allow it to sense, process, communicate, and act. So, an IoT enabled device consists of five key components. Let me show you the diagram. One is the sensor, another one is actuator, then microcontroller, then transceiver, and radio frequency identification. So these five key components are very important in IoT devices. So a sensor. So a sensor is a device that detect, or it is going to measure the changes in the environment and convert them into an electronic signal. So the sensors will collect the information from the surrounding environment. They may measure the temperature, humidity, light, pressure, motion, heart rate, chemical properties. So after measuring, the sensor convert the observations into an electronic signal. And then the actuator. So the actuator is going to receive an electronic signal from a controller and respond by interacting with its environment to produce an effect on some parameter of a physical, chemical, or the biological entity. So an actuator is going to be a device that will receive a control signal and perform a physical action. After this, we have microcontroller. See, a microcontroller is a small embedded computer that control the operation of the IoT device. So here, the microcontroller is going to act like the brain of the IoT device. So it receive the sensor data, it process the information, it make decisions, it control the actuator, it can coordinate the communications also. After that, we have transceiver. See, a transceiver is a communication component that both the transmits and receives the data. So the IoT devices communicate using this component transceiver. So the common wireless technologies used in this one is Wi-Fi and Zigbee. So the transceiver allow the device to exchange the information with other IoT devices, with other cloud systems, with other mobile applications also. And then we have the fifth component, that is radio frequency identification. So RFID, which is the technology that use the radio waves to identify and to track the objects. So the RFID will enable the automatic identification without the physical contact. So it is commonly used for inventory tracking, for the asset management, for the product identification, and for the access control also, so with all these five components, an IoT-enabled device integrate the sensor to collect the environmental data, and microcontroller to process the information and make decision, and an actuator to perform the physical action. A transceiver is to used to communicate with the other devices or cloud systems, and RFID technology is used to identify and track the objects, enabling intelligent monitoring, communication, and automation within the IoT environment. And then now we have the concept of the IoT in the context of cloud technology. See, let us understand how these IoT devices will fit into a complete enterprise environment. Because, see, an IoT device does not usually operate independently. Instead, it is going to be the part of a larger ecosystem that includes either enterprise network, third-party network, cloud computing services, data centers, core networks, fog networks, smart thing networks like this. So an IoT device is only one part of a much larger system. To understand how the IoT works, we must look at the complete environment in which it is going to be operated. And that environment may include IoT devices, enterprise networks, third-party communication networks, and cloud computing systems also. So an enterprise network is the internal network that is used by an organization to connect its computers, servers, IoT devices, and also the applications. So the enterprise network will connect the employees, IoT devices, servers, databases, internal application. So it allows the devices inside the organization to communicate very securely. See, here the thing is that the IoT devices operate together with the enterprise network. So the third-party networking services and cloud computing platforms also involved in this. So here the enterprise network will connect the internal device and applications. The third-party network will enable the external communications, and the cloud computing will provide the storage, processing, management, and the remote access. So this will allow the organizations to efficiently manage and utilize the IoT data across the entire enterprise environment. So to handle this, we have two important mechanisms. One is edge computing and another one is fog computing. So to improve the efficiency and reduce the delay, the IoT system use the edge computing and fog computing because, see, modern IoT systems, they contain thousands of sensors, millions of connected devices. So if every sensor continuously send all the data directly to the cloud, the network will become overloaded. So to solve that problem, some processing is performed closer to the IoT device. So here the first thing is we have edge computing. So edge computing is a platform, or you can say, sorry, sorry for the. So the edge computing is the mechanism for computing of performance at the edge of the enterprise network where the IoT device like sensors and actuators are operating. So the edge computing will include sensors, actuators, smart devices and all. So these devices will communicate locally before the data move towards the higher level networks. Like for example, there is a smart factory. They have temperature sensors and robotic arms communicating directly on the factory floor before the data is sent to the cloud. So Another way, we have the gateway. A gateway is the device that connect IoT device at the edge with large communication networks. So the gateway is going to act as a bridge between the IoT device, enterprise network, and the cloud service and all. After that, we have the gateway functions. See, the gateway will allow the IoT devices to communicate with the enterprise network and also the cloud platforms. And then the protocol translation. See, different IoT devices may use different communication protocols. So here the gateway translate these protocols so all the devices can communicate correctly. So here, instead of forwarding every individual sensor reading, the gateway can combine multiple readings into summarized information. So this will reduce the network traffic. After that, the important topic we have, that is fog computing. See, the fog computing extends this concept by processing IoT data close to the sensor, reducing the need to send all the raw data to the centralized cloud storage. The fog devices will perform the operations like evaluation, formatting, expanding, decoding, dis- distillation or reduction, and assessment by making the data processing more efficient before forwarding information to the cloud. And then the core, or you can say it as backbone network. See, this network is going to create the high speed communication infrastructure which can connect different fog networks, enterprise networks, cloud facilities, and also other external networks. See, a core or backbone network is a high speed communication network. So the backbone network serve as the main communication highway of an organization. Instead of connecting the individual IoT devices, it will connect the entire network together. So the benefit of this mechanism is it will provide high speed communication, reliable connectivity, redundancy will be reduced, high capacity will be there, the enterprise wise integration is possible, the cloud connectivity is possible, the database access is also possible. See, the thing is that the core or backbone network is going to serve like a high speed communication infrastructure that interconnect the geographically dispersed fog network, and it is going to provide the access to the external networks which can utilize the high performance routers and high capacity transmission lines with redundant routing for reliability, and connect the enterprise resource like large database servers and cloud private cloud facilities and all. So then we have the IoT security and privacy requirements. See, according to the ITU-T recommendation, we have Y.2066, which define the security and privacy requirements for the Internet of Things. These requirements will include the communication security, data management security, then service provision security, integration of security policies and techniques, mutual authentication and authorization, and the security audit. So in each of these, like we will protect the data while it is transmitted between IoT devices, networks, and cloud systems. And also we will protect the stored, managed, and processed IoT data, where we can ensure the IoT services are delivered securely by combining multiple security policies and techniques for the comprehensive protection. Mainly, we will verify the entities of communicating parties, and also we can control the permitted actions, where we can review the system activities and security events to identify the problems and to verify the compliance and all. So with all this, it is going to provide the entire life cycle of data in an effective way, from capture and storage to transfer, aggregation, processing, and service provision. So the IoT gateway security functions, if you see, because earlier we have learned what is IoT gateway, and that gateway connects the IoT devices to the enterprise network and cloud systems. So here we are going to mainly focus on specifically on the security responsibilities of the gateway, on the security responsibilities of the gateway. So if you see here, the IoT gateway is going to be the key security component in the IoT deployment. So the ITU-T recommendation Y.2067 policy clearly specifies that the gateway should support the device identification, one way or mutual authentication with the device, mutual authentication with applications, the data security during the storage and transmission, and privacy protection, self-diagnosis, self-repair with remote maintenance, firmware and software update, and automatic or application-based so together, all these things, the functions are going to help and ensure that secure communication, secure device management, and reliable operation throughout the IoT environment. So mainly, it is going to ensure the secure and reliable IoT deployment. And then we have IoT security environment. See the Cisco, which is one of the best companies that have developed an IoT security framework, which help the organizations to understand where the security should be applied throughout an IoT system. So here in various stages, various policies will be implemented effectively, because when you implement all this security environment, the main benefits of this framework is the security across all IoT layers will be effectively considered. Then the protection of smart devices is possible, the secure networking is possible, secure cloud services are possible, controlled user access is possible, protecting against the tampering is possible, data confidentiality is possible, secure internet communication is also possible. See, with all these possibilities, the Cisco IoT security framework provide a simplified version of the World Forum IoT reference model, and this model consists of four architectural levels. One is smart objects or embedded systems, smart objects or embedded systems, and then fog or edge network, then core network, and the data center or cloud. So to protect these levels, the Cisco has defined four security capabilities that span entire the architecture. Role-based security we will be having, anti-tamper and detection role will be capability will be having, data protection and confidentiality capability will be having, and also the internet protocol protection will be there. So together all these capabilities, it will provide a comprehensive security for IoT devices, network, and also the cloud services. And then securing of IoT framework. See, the secure IoT framework clearly tells that the core security functions are going to protect the IoT device and their communication throughout the network. So the secure IoT framework will consist of four main security components. One is authentication, another one is authorization, the network enforced policy, and then the secure analysis, visibility, and control. So authentication is going to identify the IoT devices through the automatic fingerprinting before granting the access. So the authorization is going to control the resources and services that authenticated devices may access. The network enforced policies securely route and transport the IoT traffic while it is enforcing the security rules across the infrastructure. So finally, secure analytics will provide centralized visibility of IoT devices, and it enable the administrators to configure the device, apply the patch updates, and implement the threat countermeasures, which can be ensuring the secure and efficient management of the IoT environment. And then we have a very important technology that is called the practical security solution, that is designed specifically for resource consideration constrained IoT devices, which is called mini sec. So It is a open source security model for the TinyOS operating system, and here it provide the confidentiality, authentication, and replay protection while consuming very little memory and energy. So making it suitable for very small embedded systems and all. So the MinSec is a lightweight open source security module that is designed to provide security for TinyOS based on the embedded IoT devices and all. See here, the TinyOS typically requires 48 KB of code and 10 KB of RAM, which will be making it suitable for tiny sensors. Minisec will provide the link level security by offering the confidentiality, authentication, and the replay protection while it is using a very little memory and energy. So that means it support two operating modes, single source communication and multi-source broadcast communication, which will be making it an efficient security solution for the resource constrained IoT environment, for the resource constrained IoT environments. See, after this we have the features. See, the MinSec is designed to meet six important security and performance requirements. Number one, the data authentication. So the data authentication means verifying that a message come from a trusted device and it has not been altered during the transmission. So the authentication is going to provide two important guarantees. What is that? The sender is legitimate and the message has not been modified. If either condition fails, the message is rejected. And then confidentiality. So the confidentiality means only the authorized device can read the transmitted information. So MinSec will protect the communication by preventing unauthorized users from viewing the sensitive sensor data. After that, the replay protection. See, an attacker may capture a valid message and retransmit it later. So here the MinSec will detect such replay attempts and reject the duplicate packets. And then the freshness. See, freshness means ensuring that the received message is most recent and not an old or delayed transmission. Because see, many IoT sensors measure the values that change continuously, like temperature, heart rate, humidity, air quality. Using old data that could lead to the incorrect decisions and all. And then the low energy overhead. See, it is achieved by minimizing the communication overhead and by using only the symmetric encryption, only by symmetric encryption. So the IoT devices will operate on limited battery power. The MinSec will reduce the energy consumption by sending very fewer communication messages, and it will be using only the symmetric encryption, which require less processing than more complex encryption methods and all. So with all this, it is going to provide an efficient security solution for the resource constrained IoT devices and all. So with this, we completed this module, and we have another module in this week's content. So that will be available as a recording to you all by tomorrow. So students, I repeat, the assignment 2 is already available on the Blackboard. Please try to access it, and you can start writing your solution. And also please submit your solution on or before the due date. So if you have any queries, please feel free to ask, or else you can write an email to me. And thank you so much for joining today's session. The attendance will be published on banner system as early as possible by today or tomorrow. Okay, so thank you so much. See you all in the next class.